Okay, section 12.4. Let's see if I can get through this one in my 15-minute time span. So to begin, where can an angle be placed in relation to a circle? What types have we seen? Take a second and flip back through your notes. Where have angles been placed? We have seen angles placed on the center of a circle. Do you remember what they're called? What's their relationship to their intercepted arc? Where else have we seen circles placed? We've seen them placed on the circle. What are these ones called? What's an inscribed angle's relationship to its intercepted arc? So we've seen arcs placed on the center of a circle and on the edge of a circle, but where else could they be placed? We could place them so that they're inside the circle. Picture not necessarily being on the center, but made by chords where an angle is within the circle. The other thing we can do is we can make angles so that the angle is outside the circle. So where the vertex isn't necessarily on the center or the edge, but someplace inside the circle or someplace outside the circle. So let's investigate some of those properties. I have a GeoGebra exploration, and this is linked in section 12.4 in the website. See if you can spot the relationship. And it says, caution, angles are rounded to the nearest degree. So I'm going to move these chords. So the inside angle is 121, but look at the relationship out here. It's not the same. Now it's 98, that one's 70, that one's 109, and I can change them all. Open this app up if you'd like and kind of play around with it for a little bit. What do you see as the relationship? Also, we can have it on the outside. I can change where the chord meets. Right now the angle is 12 and the arcs are 35 and 59. But as I move these, let's see, what does it let me move? So here the angle is 20 and this 14 really goes down here, and 52. So let me open this up a little bit. So it's not letting me open up the angle, but it is letting me kind of play around with where it is. So there's 22, 25, and 69. There is a pattern here. Let me tell you what it is. The measure of an angle formed by two lines that intersect inside a circle is half the sum of the measures of the intercepted arcs. So take a peek at what this looks like. If we're talking about this one labeled angle 1, and I'm sure we could talk about the other one, they're vertical, the measure of angle 1 equals half the sum of those two intercepted arcs. Come on, purple box, move. There it goes. So look back, grab your calculator, add up the 70 and the 92. Now divide it by 2. Does it give you something close to 81? Move them someplace else. Open this up on your own. And our arcs are 76 and 70. Add them up, divide by 2. Should give you 73 or close to it, and they're telling you over here that be careful that it's rounded. So as you move any of these chords, the relationship between this angle in here marked 115 is that it equals, the 115 equals 1/2 the measurement of the 70 added to the 159. Try it. Does it? It should. All right, so let's try that. They want us to find the measure of angle x. Well, I know that x equals half those two things added up. Well, those two things added up, divided by 2 or multiplied by half, x ends up equaling 68 degrees. The other relationship is when angles are outside the circle. And again, it's going to be half, but this time it's the difference. And if you look at the angles, you can kind of see that because this is on the outside, this one out here has to be smaller, take it away to account for half of that inside space. And there's a couple different ways that these can be drawn. In this first diagram here, we have two chords. In the second one, we have a tangent line and a chord. And in the third one, we have two tangent lines. But the angle is still on the outside. That outside angle, regardless of how it's drawn, is always half the difference of the two intercepted arcs. So a couple of examples. The first one says, what is the value of each variable? So we're trying to find the measure of W. Oof, that got really small. So I know that this angle, 70, is equal to 1/2 the difference. So we've got to do the larger one, which looks like the W, minus the 110. It's a formula, or not a formula, but an equation to solve. I'm going to multiply both sides by 2. So 170 equals W minus 110. Get the 110 to the other side. W should equal 250. And check it. 250 minus 110 divided by 2 should give you 70. Looking at the next one. This time I'm trying to find the angle, and it's going to equal 1/2 the difference of these two. Well, the 110 has to come first because it's larger. So 110 minus 30, have it, y ends up equaling 40. And for letter C, this one is drawn with a chord and a tangent, but still the same relationship. That 20-degree angle equals 1/2 these two intercepted arcs. The 95 appears to be larger, so I'm going to put it first. And this is another equation to solve. Times both sides by 2. 40 equals 95 minus z. Add the 95 to both sides. Oh, I'm sorry. 95 is positive, so I need to subtract it from both sides. Don't freak out. Remember, that z right there is a negative. So it's negative 55 equals negative z. So z equals 55. The next page, I think is the last one to this, has a handful of practice. I think for me the hardest part is seeing which angle kind of goes where. So hopefully 1 and 2 should be pretty easy. Give those a shot. Pause your video and just kind of see what you can do. Okay, take a peek at the answers. Hopefully problem 1 and problem 2 went okay. Both of those needed you to recognize that the exterior angle equaled 1/2 the difference of the arcs. Number 3 started getting a little bit crazy, so I tried to write over things. Hopefully you guys can understand it. I'll talk you through it. Angle Y I wrote over in blue. It's an inscribed angle, so it's half of its whole arc. What I recognized is that because I knew that this part of the circle was 160, that, let's see, I knew that if I could find, how did I do this? Let me back up for a second. I think I got the measure of angle X first. So, okay, back up for a moment. Angle Y is an inscribed angle, so its measurement will be half of this arc, which we'll get it in a second. Angle X is this missing piece that's still here in blue of the original. So I knew that this 50 degrees, which is the outside, equals 1/2 the difference of its two intercepted arcs. So I needed to subtract 160 minus X. When I did that calculation, 50 equals half times whatever, multiplied the 2, subtracted the 360 or 160, I ended up with X equals 60 degrees. So this rest of the arc was 60. So from where that angle Y is, this arc is 60, this arc is 160 added to 60, subtracted from 360 all the way around, I was able to get that what's written in purple was 140. The inscribed angle was angle Y, so half of it was 70. Hopefully number 4 isn't too crazy, recognizing that we have 120 degrees of the circle, so the remainder part of the circle must be 240. Number 5, took me a second to see. What I did was I took the angle X, which is inside, and I colored it all in blue. Angle, or the Y degrees, is actually for that dark black part. So I recognized that for X, I needed this small piece here. Well, this is half of a circle. This entire arc is 180. So I was able to get that this small piece was 50. As X extends through, it's intersecting the other half of the circle. So the measure of angle X equaled 1/2, 180 plus 50, so it gave me 115. Then what I did was I redrew the picture for Y because I just couldn't see it with everything that I drew on it. So let me draw it with you for a moment. We have a circle with a diameter. 53 is out here, and one of its values is going inside, maybe not the best drawing, and the other one is going over here. Angle Y is the difference. Yeah, not perfectly drawn. But what we need to recognize is that 53, this outside value, equals half the difference of those two pieces. This is 180. I needed that value, this little sliver here. So I set up that 53 equaled half, 180 minus Y, multiplied both sides by half, subtracted the 180, gave me a negative, but good thing the Y was already a minus, so it worked out being that Y was 74. I ran out of space for number 6, so I put it on the next page. In number 6, all of these arcs are marked congruent, so I knew that each arc was 72 degrees. 360 divided by 5 congruent arcs, they were all 72. I started with angle Y, and I noticed that it was an inscribed angle, and inscribed angles are always half of their arcs. So this inscribed angle Y here was intercepting 2 arcs. Wait a second, if it's intercepting 2 arcs, then it's not going to be 36 degrees. 72 plus 72 is 144, so that angle is actually 72. Then I looked at angle X, and let me erase some of this stuff. And I saw that angle X came in through here. So I needed this value and all of those. So angle X equaled 1/2 the 72 degrees added to 72, and 72 is where I got the 144. So I ended up with X being 108. Let's see, is that the last one or was there one more? Thinking. One more problem. A satellite in orbit is in orbit above the Earth's equator. Has an angle, let's see, 2 tangent lines. So tangent to the equator, which is running through, and this is 17.5. What is the measure of the arc that is viewed from the satellite? So they want to know what is this arc here that is viewed from the satellite. Well, we don't know how big that is. I don't know that it's 180 because that, yes, this is half. It's going to the equator, but that doesn't mean, we'll just hold on for a second. So this is X. What if 2, it was drawn further here? It doesn't have to necessarily be drawn to the edges. So we don't know how big X is. Eek, I'm running out of time. I only get 15 minutes of video. So let's say I draw it into the diameter. This is 17.5. I don't know how big this is, but I know because it's 360, that other measurement must be 360 minus X. So 17.5 equals half of 360 minus X, this whole outer piece subtracted from the inner piece. I'm going to multiply both sides by 2. So that gives me 35 equals 36 minus combined like terms, 2x. Go ahead, move some things around. I ended up, when I was all done, with x equaling 162.5. Whew, just made it. Thanks.